Gold, a metal that for centuries has symbolized wealth, power, and beauty, is actually one of the rarest elements in Earth's crust. But its origin lies far beyond our planet. To truly understand gold, we must look back billions of years to the moments when dying stars shaped the universe with their colossal explosions. Unlike lighter elements such as hydrogen, oxygen, or carbon, which are formed in the cores of stars through nuclear fusion, gold does not emerge from this process. With an atomic number of 79, gold requires an environment with extremely high neutron density, something that only occurs during supernova explosions or the collision of neutron stars. When you look at a gold bar, you might only see its weight and shine. But behind it lies a story of billions of years of cosmic formation, centuries of mining, and decades of economic accumulation. Around 4.6 billion years ago, as the solar system began to form, clouds of cosmic gas and dust containing gold particles gradually condensed, giving rise to the Sun, planets, and asteroids. Earth also inherited some of this material. However, during the early stages of Earth's formation, gold, due to its high density, was drawn toward the planet's core. As a result, most of Earth's gold resides in its core, inaccessible with current technology. Despite this, only a small amount of gold remains in Earth's crust, and that limited quantity has been the source of all human gold extraction to date. Geological processes such as volcanic activity, tectonic plate movement, and hydrothermal circulation have helped transport gold from deep within the Earth to the surface, where it accumulates in mineral veins or alluvial deposits. Geologists, by studying special rocks called xenoliths fragments brought up from the Earth's mantle, have found evidence suggesting that gold may also originate from the mantle. These findings indicate that gold reaches the surface not only from the core, but also from deeper layers of the Earth. Currently, it's estimated that humans have extracted around 200,000 to 260,000 metric tons of gold. If shaped into a cube, this entire amount would form a block roughly 22 meters on each side, minuscule compared to the volume of the Earth. However, the amount of gold in Earth's core is vastly greater. Some calculations suggest that if we could access the core, it might contain over 1 million times more gold than has ever been mined. In addition to Earth's internal origins, some studies have shown that meteorites also played a significant role in delivering gold to the planet's surface. During the early stages of Earth's history, heavy asteroid impacts contributed gold and other dense metals from these celestial bodies to the Earth's crust. In Mendeleev's periodic table, gold with atomic number 79 rests between platinum and mercury. Yet despite its calm and lustrous appearance, gold is the product of one of the most violent and rare nuclear reactions in the universe. To create a single atom of gold, one needs more than a laboratory. You would have to journey into the heart of dead stars. Inside stars, lighter elements such as hydrogen, carbon, and oxygen are formed through nuclear fusion. But this process only continues up to iron. The creation of heavier elements like gold requires an environment with extremely high neutron density, where nuclei absorb dozens of neutrons in fractions of a second and transform into new elements. This process, known as the R process, occurs only in supernova explosions or neutron star collisions. But can gold be made in a laboratory? In theory, yes. If we can change the number of protons in a nucleus, we can create a new element. For example, if we remove one proton from Mercury, which has 80 protons, we obtain gold with 79. Or if we add one proton to platinum, which has 78, we again arrive at gold. This process is called transmutation, the transformation of one element into another through nuclear reactions. In past decades, Scientists at institutions such as Oak Ridge and CERN have attempted to trigger such reactions using particle accelerators. In ultra-fast collisions of lead ions, a minute amount of gold was produced. However, this gold amounted to only a few picograms, and the energy required to create it was thousands of times greater than its actual value. From an economic standpoint, producing gold in a laboratory is futile. According to the official report of the World Gold Council, by the end of 2024, humanity had extracted about 216,265 tons of gold. With the addition of production in the first half of 2025, this figure has reached approximately 218,000 tons. But this represents only the gold accessible on Earth's surface. The vast majority of Earth's true gold is buried in its core far beyond reach, at depths no current technology can penetrate. Geological studies suggest that more than 99% of Earth's gold lies in the core, and if we could somehow extract it, we could cover the entire land surface of the planet with a 50-centimeter layer of gold. On the surface, gold exists in two forms: extracted gold and stored gold. The world's annual gold production is about 3,600 tons, primarily supplied by countries such as China, 380 tons, Russia, 330 tons, Australia, 284 tons, Canada, 202 tons, and the United States, 158 tons. The second part, namely stored gold, tells a different story. This gold is not found in mines, but kept in the vaults of central banks as a currency reserve, a tool for controlling inflation, and a symbol of financial trust. In 2025, the United States, with 8,133 tons of official gold, is the largest holder of gold reserves in the world. This amount represents more than 1/4 of all official reserves globally, most of it stored in the famous Fort Knox vault. Following the US, Germany with 3,352 tons, Italy with 2,452 tons, and France with 2,437 tons rank next. These countries, especially during times of financial crisis, have preserved gold as an economic shield. Russia with 2,336 tons and China with 2,280 tons have also actively increased their gold reserves in recent years, part of a strategy to reduce dependence on the dollar and foreign sanctions. Among other nations, Switzerland with 1,040 tons, India with 876 tons, and Japan with 846 tons also hold significant reserves. Alongside official reserves, a large portion of gold is held in the form of jewelry, private investment, and electronic industries. According to data from the World Gold Council, about 45% of the world's gold exists as jewelry, 22% is investment coins and bars, 17% in central banks, and 15% in other applications. But the key question is, why do countries store gold? The answer is simple: trust. Unlike digital currencies or printed banknotes, gold has intrinsic value. In times of inflation, banking crises, or political instability, gold serves as a foundation that helps preserve public confidence. That's why central banks not only hold gold, but also move it, repurchase it, or even use it as collateral when necessary. India, as one of the world's largest consumers of gold, holds over 25,000 tons of gold in the form of family jewelry, more than the official reserves of many nations. In the 20th century, gold entered the realm of economics. For decades, the gold standard backed national currencies. Until 1971, the US dollar was convertible into gold. But after abandoning that standard, gold shifted from a monetary tool to an investment asset, a safe haven against inflation, crisis, and instability. Today, Gold plays a role in technology as well. In computer circuits, medical equipment, and even spacecraft. Thanks to its high conductivity and resistance to corrosion, gold is used in the manufacture of precise and critical instruments. In cancer treatment, radioactive isotopes of gold are used as localized sources of radiation. Gold forged in stellar explosions and pulsing through the heart of global economies has journeyed across time in ways both wondrous and unfinished. If this story resonated with you, don't forget to like the video and subscribe to the channel to help us uncover the hidden horizons. Each week, we return with fresh episodes exploring history, science, and the unseen mysteries of our world. Join us as we lift the veil on the unknown and rediscover the world through a new lens.